Here we need to estimate the mean temperature in degrees Fahrenheit with the following sample temperatures. The first thing I want you guys to notice is there are 1, 2, 3, 4, 5, 6 temperatures in this sample. Find the 95% confidence interval. Enter your answer as an open interval with parentheses accurate to 2 decimal places. Okay, so the video that's listed here in my open math has a not a complicated, but it has a bit of an involved spreadsheet from Excel. If you've been working through our class, you maybe remember the Excel spreadsheets we had where we calculated what we need here from a list, which is the mean, certainly, although not too bad because we have 6, and later on the sample standard deviation. So if you want to use your spreadsheets from previously, that's perfectly fine. In this example, I'm going to do this kind of by hand or with just a basic calculator in case you wanted to see how to do it without using a spreadsheet. So for starters, since we're dealing with the mean, since we're talking about the mean, we're going to be having our confidence interval in this format. It will be our mean minus our error and our mean plus our error. And the error for the means is given by the formula t sub alpha over 2 times the sample standard deviation divided by the square root of n. Okay, a couple of things that we know already. We know or can figure out n. That's pretty easy. N is 6. We can figure out relatively easy the t value. So let's see, our alpha from a 95% confidence interval, our alpha is 0.05. So alpha over 2 would be 0.025. And we have degrees of freedom would be 6 minus 1 would be 5. So looking that up on our student t distribution chart, our t of 0.025 with a degrees of freedom of 5 gives us a t value of 2.571. Okay, so now we have the error is 2.571 and the n is 6. So 2 big pieces that we need to calculate here are, let's see, let me highlight these in blue. The mean, because that will come as from our confidence interval, and the standard deviation. Okay, remember to find the mean, you're going to add up all of your x values and divide by n, divide by 6. So we're going to do 68.2 plus 66.8 all the way up to plus 71.9 and divide that by 6. And when you do that calculation, you should get 66.1167, rounding. What most people forget in this problem is how to calculate the sample standard deviation. So if you look way back at the beginning of the semester, the formula for the sample standard deviation is the sum of all of your entries, so 68.2, 66.8, subtracted the mean, square, divided by n minus 1, all square rooted. So the first few of those would look like, let's see, 68.2 minus 66.117 squared. And then 66.8 minus 66.117 squared. And so on until we get to 71.9. And then n minus 1 is 5. So when you do those calculations, your standard deviation should be 4.182. And we'll need that for our formula for our error. So if you don't choose to use a graphing calculator or a spreadsheet, then it's not too terrible to figure out what the mean is and what the standard deviation is for our sample. It's not too terrible, but you do need to do those calculations. Okay, almost finished. When we do these calculations now, we have 2.571 times 4.182 divided by the square root of 6. We're left with an error of, where'd my error go? 4.389. Okay, so now our new confidence interval. Mu minus the error, mu plus the error will give us 66.117 minus 4.389 and 66.117 plus 4.389, which, when we perform those calculations, we should get approximately 61.73 when we round to 2 decimal places, and 70.51 when we round to 2 decimal places.